So if the substitution u is equal to root of x plus 1 is used, rewrite this equation here in terms of u, and of course limits of integration have to change, so no longer 0 and 3 but some other numbers. Let's take this to a bigger space and start working on it. And so here we're going to be taking that u is equal root of x plus 1. I'm going to be right now differentiating everything. Differentiate, and we'll get du is equal to 1 over 2 root x plus 1 times dx. Now, don't forget that u is equal to root of x plus 1. And so that means I can replace the root of x plus 1 with u. So I'm going to have du is equal to dx over 2u. In other words, dx is equal to 2u du. Okay, that's one thing. How about x here? What to replace it with? So look, u is equal to root of x plus 1. Let's just square everything. We'll get u squared is equal to x plus 1. That means x is equal to u squared minus 1. Now I'm ready to replace things here. Now look, dx will be replaced with 2u du. Instead of x, I'll put u squared minus 1. And instead of root of x plus 1, I will put u. And now it's time to simplify by taking out the u terms, right? So we're going to be having right now 2 du u squared minus 1. One more thing left, which is the limits of integration 0 and 3 should no longer be there because now we changed everything to be in terms of u. So how do we get the new numbers? Let's talk about it, right? So now we know that u squared minus 1 is equal to x. We also know that one time x is equal to 0, one time x is equal to 3. When x is 0, we're going to have u squared minus 1 is equal to 0, u squared is equal to 1, so u is equal to 1. And when x is 3, we're going to have u squared minus 1 is equal to 3, u squared is equal to 4, and therefore u is equal to 2. That means that the new limits of integration will be from 1 to 2, and that's going to be our answer. Let's move on to question 2. In question 2, we're given u is equal to the root of x minus 1, and we're supposed to turn this expression into a u form with changing the limits of integration. First thing is u is equal to root of x minus 1. Let's now differentiate everything. That means we'll be getting du is equal to 1 over 2 root x minus 1 dx. Now as you know, u is equal to the root of x minus 1. Therefore, I'll go ahead, I'm going to be replacing the root of x minus 1 with u dx. And now it's time to simplify. So we're going to say right now dx is equal to 2u du. Okay? Now, also one more thing, which is that if u is equal to the square root of x minus 1, if I square everything, I'll get u squared is equal to x minus 1. That means x will be u squared plus 1. Okay? Now I just need to move on to bigger space and continue this. Okay, so now basically we can also find the new limits of integration because we know that one time x is equal to 2 and one time x is equal to 5. So we're going to have u squared plus 1 is equal to u squared plus 1 is equal to 5. U squared is equal to 1, u squared is equal to 4, 1 time u is equal to 1, 1 time u is equal to 2, from 1 to 2. So it's not choice D. Okay. Let's now continue. So right now I'll be coming here, I'm going to be replacing things. So instead of 2 to 5, I'll make it from 1 to 2. And instead of root of x minus 1, I'll be replacing that with u. And instead of x, I'll be replacing that with u squared plus 1. And instead of dx, I'll be replacing that with 2u du. And now what happens is I'll be simplifying. So I'm going to have 1, 2 u squared plus 1 du. Yep, it's going to be choice A.